We've established that UTXOs function as digital banknotes in our wallet, being destroyed and recreated with each spend, and linked through transaction hashes to track ownership and prevent double spending. Next, we'll explore transaction serialization, examining the fields and hex format used to build raw transactions. We'll start with the simplest case, a regular transaction with one input and two outputs. Transaction serialization encodes a transaction's data structure into a standardized byte format for network transmission, storage, and hashing. The format we'll be analyzing is the hex representation of this serialized data. It's worth noting that this finalized hex is in reversed byte order, where each two-digit position has been reversed. For example, the version field 0100 represents the actual value 0001, which equals 1 in base 16 hex format. The fields needed for processing this transaction, in their required order, are as follows. Version and serialization format. This is a version 1 transaction with full serialization. The transaction version and serialization format allow the network to interpret the transaction data correctly. The version number ensures transactions remain compatible with older nodes in the network. By signaling the version used, newer transaction formats can be introduced without breaking compatibility with earlier versions. Input count. This transaction has only one input, though as previously discussed, a transaction can have multiple inputs or UTXOs to make up the required amount. This field tells the interpreter how many inputs and their associated fields to process. Each input contains 4 fields. Input 1. Transaction hash. This references the transaction ID of the previous transaction being spent. Output index. This specifies the index of the output in the reference transaction being spent. Tree. This indicates whether the transaction belongs to the regular tree or the stake tree. Decred employs a dual tree structure for its transactions. Sequence number. In a Decred transaction, the sequence number determines how transactions can be modified or replaced under certain conditions. The value shown here indicates the transaction is finalized and can no longer be changed. Output count. This transaction has 2 outputs. Like the input section, this field tells the interpreter how many outputs and their associated fields to process. Each output contains 4 fields. Output amount 5.68522529 DCR. This is the amount of DCR being sent to the specified output. Script version 0. This version number signifies how the output should be interpreted. Public key script length value of 19, indicating the script in the following field is 25 bytes long. Public key script P2PKH pub key hash. This is the script that must be satisfied to spend the output. The same structure is repeated for the second output. After this section, we have lock time. 0 equals no lock time. This field specifies the earliest time or block height when the transaction is allowed to be included in a block. Expiry. 0 equals no expiry. Expiry is an optional field typically set to 0 when not in use. Number of witnesses. This transaction has one witness. Like the input and output sections, this field tells the interpreter how many witnesses and their associated fields to process. Each witness contains 5 fields. A witness transaction input contains the data necessary to prove that an output can be spent. The fields include input amount, 5.68602.846 DCR. This is the amount of coins that the output being spent transfers. Block height, 998,502. This represents the height of the block containing the transaction in which the output being spent is located. Block index, 12. This is the index of the transaction in which the output being spent is located. You can track this back by going to the block height and then locate the transaction, in this case from the regular tree. This is easier to see by visiting the block's API data. Signature script length. This field tells the interpreter that the script in the following field is 106 bytes long. Signature script. An ECDSA signature plus public key that redeems the input. This script satisfies the requirements of the script in the output being spent. Each transaction includes this data for verifiability. To link this information efficiently, the next step is to hash the information, excluding the witness data, to form the transaction hash, also referred to as the transaction ID.